So I will start the recording now. Okay. So in week three, we are in week three right now, and we will be starting with the Newton's law of motion. We will be starting with motion. What is force? We will be discussing about the contact force, non-contact force. We will be little bit diving into what is gravitational force, and also we will be discussing what is friction and how we can analyze those things. Okay. So let's understand what is force first. So force is technically interaction between two objects. I will be giving you an overview while writing also. So it's an interaction between two objects that causes a change in the motion of the object. So the very first thing is, so it's a motion, yeah. So force can be done by two methods. Either you can push something towards yourself. For example, this is me. If I'm taking something towards me, then this is known as push. And if sometimes I'm pushing it, for example, in this condition, I will use a little bit more strength of the marker so that you can understand. So in this condition, if I'm pushing this object, I'm sorry for my handwriting. Anyways, so if I'm pushing object this side, then this condition is known as push, yeah. And this condition, when I'm taking it towards my side, then it is known as pull. I'm sorry if I made it wrong. And yeah. So this is push and pull. So what causes push and pull? Whenever we apply something on it, and momentum, or maybe, yeah, and momentum on an object, then it gives us a result as a force. So simply, force is an interaction between two objects that causes a change in the motion. Here the object one is me, this is object one, and this is object two. So simply, this is force. So we don't have to read the definition, we don't have to memorize the definition. However, we need to understand the concept because we are going to deal with the practical examples. Anyways, so what impact force of have an object? So first of all, makes it move, makes it speed up, makes it slow down, stop it, cause it to change direction, or cause it to change shape. Even changing shape is a possibility, and we can take an example of a ball or a balloon. If we press it, then of course the change shapes. uh, there is a change in shape. Anyways, let's understand a very important concept and very important scientist who was known as Isaac Newton. This guy I'm teaching you because might be we will be having a question in general knowledge, but not in physics for sure. They will never ask you a question, who is Isaac Newton in physics? But we need to understand who is Isaac Newton, just for the sake of physics and just to give him credits, because of him today we are learning Newton's law of motion, and because of him we are able to analyze everything. So he was a renowned physician and a mathematician from England. In 1687, the correlation he gave the correlation between force and motion. Today we have three laws of Newton. So Isaac Newton gave us three laws. We will be discussing each and every law step by step. The first law, also known as the law of inertia. First, we will be discussing the first law, law of inertia. The second law, which we use maximally mathematically express as force is equals to mass into acceleration. So we have to use this formula throughout our chapter mostly. So second law is very important. We will be discussing what is second law in words also, but for now you have to remember, whenever the word F is equals to ma comes, this is Newton's second law of motion. Third, we have third law, which is simply says that each and every reaction has an equal and opposite reaction. So whatever, if it even applies in a psychological world. So whenever someone speaks bad to me, eventually I speaks bad to that guy. When someone speaks good to me, eventually I speak good to that guy as well. But that is not what Newton meant. Newton meant that whenever I'm applying a force, I will be showing you with the example of a diagram now. So let's understand the Newton first law, also known as law of inertia. So I will write here Newton first law. And Newton first law states that a body remains at rest or in motion unless and until an external force is applied to it. So you see the body is moving without, it's going, I'm sorry, yeah, it's traveling here without any no external force, so it is still straight line, yeah. But when I have applied an external force here, so you see the body has changed its position. So Newton's first law of motion is very simple. You don't have to like make your rocket science available in your mind. No need, because it's very simple. So I have written here also for your convenience. Newton's first law of motion states an object of rest or an object of unbalanced force remains at rest or unbalanced unless and until external force is applied to it. It is in definition form. An object in motion will stay in motion at the same speed and in the same direction unless acted to by or unbalanced force. So I hope the Newton's first law of motion is clear. Now let's move to the Newton's second law of motion. Newton's second law of motion is again very simple. It's not again rocket science. Yeah. So now we are discussing the Newton's second law of motion. And I will come back to this and I will be saying you what is inertia also. I will come back to this, don't worry. This term is quite confusing for a lot of students, so that is important. Newton's second law of motion. So mathematically, if we express Newton's second law of motion, it is force into mass into acceleration. Force is equals to mass into acceleration, I'm sorry. So here we have to remember that the force is proportional to the mass and force is also proportional to the acceleration. So the more the acceleration will be, the more the force will be. The more the mass is, the more the force will be automatically. So it is directly proportional with each other. Again here, if we see carefully, then mass is inversely proportional to the acceleration. Because if we want to write this formula as F is equals to, maybe here, and if I simply write A, then it will be F upon M, right? So you see A and M are inversely related with each other. So whenever the acceleration will be high, automatically the mass will be less or maybe low. So that is the reason here we will be understanding this concept. So now here you see there is F force. So acceleration is also A. Simple. But now you see there is a mass is 2m. The mass is m here, okay? So F is equals to m here in this condition, in the first condition. In the second condition, you see the mass is getting raised by 2 times. So the acceleration is getting decreased by half times. In the same way, if here, for example, if I am having a mass of 3m, so the acceleration will get decreased by 1 by third acceleration. Yeah. So in the same way. Now you see the force is related with, as I told you here, that force is directly proportional to acceleration. Means that if force is increasing by twice time, then acceleration will also increase by twice time. So here you can understand, if force is increasing 2f, then here the acceleration is also increasing by 2a, but the mass is the same. So very simple concept, no need to think a lot. Simple, force is equals to mass into acceleration. Force is directly proportional to mass and acceleration, and mass is inversely proportional to acceleration. So if mass increases, acceleration decreases. That is the reason if I'm having for example, a small box, and if I kick it and it goes easily away. But for example, I'm having a stone, a huge stone. I can't kick it and it will go easily because the mass is very high. Yeah, the mass of stone is very high as compared to the empty box. So that is the reason I need to apply more acceleration in this condition of my leg. Yeah. So that's very simple concept. I hope Newton's second law of motion is quite clear. Let's discuss what it does it mean in theoretical terms. Newton's second law of motion in
Hello.
theoretical. Yeah.
I have a question. Can you please go back to the previous slide?
Yeah, for sure.
So, if force is directly proportional to mass as well,
Yeah.
the force is dividing, why isn't mass increasing?
I'm sorry. The force is directly proportional to mass and what?
In the third example, the force is twice.
Yeah,
So, why isn't the mass increasing?
no, the mass is remains constant for our body. Yeah, it's mass m. If I want 2m, it doesn't matter. It's not. It's yours. You mean to say that the mass is m, so the force is 2f, so the mass should also be 2m. You mean that?
Yes.
No. The mass remains constant. It is in the question. But I want what I mean is when the force is proportional to acceleration, so they both because acceleration changes, yeah, mass is always constant. So that is my point.
Okay, thank you.
Yeah, no worries. Okay, so Newton's second law of motion here states that acceleration of an object by a force is inversely proportional to the mass. What I told you just now, inversely proportional to the mass. This thing is important. Yeah. So, and the for mathematical expression is always force is equals to mass into acceleration, and this is the 60% of the chapter, 60 or 70% chapter, because this is where what we use every time. Makes sense. Now let's move to the Newton's third law of motion. As I told you, that it states that for every action there is an equal and opposite reaction. So for you, you see this diagram which I made it here. So you see an action, there is a reaction here. There is an action, there is a reaction here. Action, reaction. So this is what Newton's third law of motion means. And technically we don't have any mathematical expression for this, but we use this concept while making the free body diagrams and another important diagram which we will be using at the time of calculations during solving the problems, I'm sorry. Perfect. Okay, so now let's understand.
Hello.
Hi.
Sir, I have a question.
Yeah, what is the question?
Sir, is Newton third law fulfills the condition of equilibrium?
Yeah, Newton's third law of condition is not valid in the equilibrium. You mean when you are standing in the wall and you're applying here the force F, so this is also applying a force L. So yes, it is valid, however, in equilibrium, but doesn't move. So if you are applying force on a wall, of course the wall doesn't move, yeah. But of course the wall is having a force opposite to you, but there is a force. So
Okay, sir.
you have to remember that when you apply force to somebody, the body also applies the force to you. That's the concept. Now I'm giving you a concept here
Okay,
with the help
thanks.
of this diagram. Yeah. Yeah. So now you know that Earth, this is Earth, and we know that Earth and Moon are Moon is rotating in the axis around the Earth, and it's since it is in orbit, that is the reason that the Moon is not getting inside the Earth. Otherwise, for example, if it would not be in the orbit, so the Moon would have collided with the Earth. Just because it's rotating in the orbit, that is the reason they have a path and they have to follow that path. Anyways, so because of the Earth's gravitational force, this moon is in the contact with it. So the if you see here Fm on E, so the force is getting applied on the moon and the moon is also applying the force on the Earth. So this is the Newton's third law of motion. Here the second example, if a block is on the surface, so you see the block that is Fb and you see the surface Fs. So the block is having an external force Fs from the surface and the surface is having a force Fb on S. So they both exchange the forces. Yeah, the same concept of which I gave just now is the wall concept. So when I push a wall, of course it is not moving, but for sure I am applying a force there, right? By the person. So what I'm applying is the force by the person, and what wall is applying to me is force of wall on the person. So this is what the concept of Newton third law of motion is. And as I told you before, we will be using this concept mostly for FBD. And let's understand what is FBD. FBD means free body diagram, and this free body diagram will help us to understand Newton's concept more precisely and more accurately. Moving back, if I want, maybe we can solve some questions. Okay, not really, not now. Okay, so moving back to the slide, let's understand a small concept of momentum. Okay, so let's take 2 minutes thing to discuss thing. If anyone is having doubt, so I can answer them accordingly. So anyone is having any doubt until now can ask me. Until now, not extra questions, not outside the syllabus. Until now,
Hello.
yeah.
Why there is a specific distance between the moon and Earth?
What? Why there is this? What is the specific distance between moon and Earth?
No, no, why?
Why is it a specific distance? Because it's nature, and come on, science can prove it for sure. And as I told you, there is an orbit here, and in the same way, Earth is also this. If, for example, if this is Sun, then Earth is also moving across the Sun in an orbit, and this is designed by nature. We can just give the answer. Yeah, it is this distance, and as I told you before, the reason behind that the moon is revolving around the Earth is because of the gravitational force towards the Earth. And why it is not coming inside the Earth? The second answer is because of the orbit, because orbit gives it a clear path. Yeah, any other questions? Logical questions? Yes, no, Riamna. What's your question?
Hello, sir.
Yeah, good morning.
Good morning, sir. Sir, the book that is with me in about the Newton third law, it is written that this explains the nature of forces. What does it mean?
This explains the nature of the forces. Yeah, okay, that's interesting. Nature of the force means, for example, this is the gravitational force. This is the contact force. So after this thing, I'm gonna move forward with the nature of the forces, and we have a lot of nature of the forces which we will be discussing. So Newton third law discuss with the nature of the forces, no doubt. Yes, exactly. So nature means the type of force, like gravitational force, contact force, non-contact force, motion due to in fluid mechanics or something like that. Yeah.
Okay, thank you, sir.
Yeah, no worries. Okay, so let's move forward with the everyone is clear with Newton's first law of motion, and I hope the definition is crystal clear. Everyone is clear with the Newton's second law of motion. I hope the mathematical expression, which is 70% of this chapter, is clear. Thirdly, I hope that Newton's third law of motion is clear, and which this force we will be using to make the free body diagrams and to explain the nature of the forces. Perfect. Let's move to the momentum. What is momentum? In the last class of physical quantities and measurement, I told you momentum is something which means how much or mass or describes the quantity of the nature. So the measure of an object resistance to change in its state of motion due to application of force is known as momentum. So momentum is simply mass in motion. So momentum is described by the letter P. You have to remember momentum is described by the letter P. And the formula for momentum, P is momentum, okay? P is not power. P is momentum, and the formula to describe momentum is mass into velocity. Okay, so momentum simply means it describes the change in mass or motion. Yeah, motion describes the, maybe 1 second, motion of mass. So P describes the motion of mass, M is mass, as you know, and V is velocity. So this formula is also important. So till now we have learned two formula. The first formula is force is equals to mass into acceleration, and the second formula which we learned is P is equals to M dot V. So these two formulas until we have learned. Makes sense. So momentum is clear. The formula of momentum is written here also. MVP is again, yeah, I will write this P with a small letter because capital P in physics usually is considered as power. That is the reason we don't get confused. Anyways, momentum is clear. Let's move forward with impulse. So impulse is a short time force. Impulse, the third formula which is important. Most of the students are from India, Pakistan, and so we have some two students from South Africa also. And recently South Africa was in semi-final of cricket. So we have a badge, right? Badge is like there is a, I know some of you don't know cricket because you are Europeans, and in Europe that is not common. Cricket is usually a game like baseball, something like baseball, something like baseball, but not baseball for sure. So there are two person. The other person is doing a bowling here. He's throwing a ball, and the guy will hit the ball with the bat. This is a bat. So the short duration of time when the strong force will be applied, very strong force, because when we hit the ball or when you hit someone, you hit with force, right? So and that hit is only for few seconds, not for a long time. And that few seconds force which you applied for that particular object is known as impulse, and it is defined by the formula F into delta t, and that delta t is change in time, and that this time is very very small. And this impulse can be also written as the change in momentum, so we can also write this as mv is equals to f dot delta t. So this formula can be used. So when a force is applied to an object, it will result in a change of momentum. This change may involve a shift in velocity, such as increase or decrease in speed or change in direction. So an impulse causes momentum change. Of course, so the ball is coming with different velocity, but it will go with a different velocity. Yeah. So that is momentum change. So impulse, simply if they ask you impulse, simply you have to use this formula, f dot delta t. And if they ask you two things, if they give you the relation of velocity also, then you can use the formula mv into f delta t. So until now we have discussed the three formulas or whatever it is. The first formula is f is equals to mass into acceleration. The second formula is which one, p is equals to m dot v, and the third formula is impulse is equals to f dot delta t. These are the three formulas we have learned so far, and the impulse can be also written as m delta v, momentum of change. Okay.
Is it capital F?
Yeah, for f is capital, because small f we use for friction. I will be telling you now. We don't get confused between a capital F and small f. Capital F is used for force and small f is used for friction. Okay.
Yes.
Perfect. Thank you.
So,
Hi.
yeah, hi. Is rate of change of momentum known as impulse or what?
Yeah, that is also correct. Rate of change of momentum is known as impulse in theoretical language. Okay, you can remember this. This is the key point. Should I highlight it with good pen? Maybe with purple. You like it? No? Let's do it with this one. All right, guys. I hope most of the things are cleared so far. Let's do some examples to understand this concept, and then we will move forward with the... Okay, inertia is important. Yeah, as I told you, I will come back to inertia in the first law of motion. So let's take an example. You guys are sitting in a bus. Terrible. Not bus, but a truck. If you're not clear Imat, then of course you will become a truck driver. I'm sorry. Okay. So let's imagine two students of my class. The yesterday's topper Mohebullah, who scored 67 marks in the mock test, and another student, Alicia. Two students, German student and Pakistani students, are sitting in a truck, and she scored 60 marks. A good score, both of you. Well, this truck is moving, and now you guys are enjoying. You're doing party. Come on, we won the exam, and of course we are scoring 75 and 80 marks in real IMET examination. Let's do party. And the truck driver is me, because I took you from Pakistan and Germany to Italy. Yeah. Anyways, so now I am in full speed, like 100 kilometer per hour or maybe more. And now suddenly I applied brake, a bad brake. And now, 1 second. Now the truck is like... So when I applied brake here, so you guys were partying and you were stable at the one position. But suddenly when I applied brake, you experienced an opposite force. You experience what? An opposite force. That opposite force is a resistive force, and that resistive force is known as inertia. Any resistive force which is happening anywhere, if you're sitting in a bus and suddenly the driver puts the brake and you felt opposite force in the opposite direction, or anywhere, that force is known as inertia. So whenever you resist something, it's inertia. Let's understand in theoretical terms. The tendency of an object to resist a change in motion. This means that an object will either stay at rest or continue moving in a straight line at a constant speed. And as I told you, simply you have to like the bus can stop and then continue again, or the bus will stop all on the sudden. So this means an object will either stay at the same position or will continue in the straight line, but you will experience a resistive force anyways. And yeah, go for it.
What is inertia?
A resistive force. This is inertia, an experience which you feel after a force is applied in opposite direction. Make sense to everyone? Come on, I gave us such a beautiful example of two beautiful people. No, you didn't understood? Anyways, don't take it seriously, okay? You have to score 90 in this, not 75 to 80. Okay. Let's go to some examples now, real-time examples which we will be doing so that we can understand the concepts. So let's take a quick overview of whatever we learned so far, and then we will move forward with the. So we were discussing about motion and force. We discussed about the force, what is force and how it is caused, and two objects are necessary involved in this thing. Then we discussed who is Isaac Newton, and a physicist and mathematician from England, born in not born, I don't know when he was born, but he discovered in 1687 the relation between force and motion. He gave three laws. We discussed the first law, which states that an object at rest will stay at rest unless and until an external force is applied to it. The second, the Newton's first law of motion is also known as the law of inertia. The second is the Newton's second law of motion, which says that force is equals to mass into acceleration, and F is written by capital F and not small f. We need to make sure about that. And mass is inversely proportional to the acceleration. If mass is increasing, so acceleration is decreasing accordingly. Mass remains constant most of the time. So state for every action there is an equal and opposite reaction. This is Newton's third law of motion. I gave beautiful example of pendulum here. So you see one pendulum is going down, so other pendulum is coming up. So this is Newton's third law of motion. Then we have the concept of momentum. I told you what is momentum. It's simply mass in motion, and momentum is written by small p. The formula is mass into velocity. Then we discuss what is impulse. Impulse is a short time force applied to any body, and I gave you the best example of cricket, baseball, where a ball is getting hit by a bat or a buzz or whatever it is known as, I don't know, for a short duration of time, and that caused a lot of momentum change. So it can be, impulse is simply denoted by F into delta t, but impulse is also written as momentum change, that is change in momentum, as Tanisha told us. So it can be written as F dot delta t is equals to M dot delta V. Anyways, so what is inertia? We discussed it's a resistive force which happens. I gave you the example how it happens, and we already discussed what is the acceleration, but just a quick overview. Acceleration is, just a moment, acceleration is change in velocity upon time. So we can write as V minus U upon T. So this is acceleration, guys. You have to remember, okay? If you want to take V2 and V1, it's fine also. But I will refer you to start using V and U. It's better for you. V is final velocity and U is initial velocity. So you know acceleration. I don't have to tell you what is acceleration. Now we have two formulas of acceleration actually. The first formula is this one, what we have just learned. Acceleration is equals to V minus U upon T. And the second formula is acceleration is equals to force upon mass. Start rearranging the things. It will be helping you eventually, okay? Yeah, so we already discussed inertia. Okay, now let's discuss about the contact and non-contact force, and then we will be starting. Or should I do it now? Let's do some examples now because students are getting bored maybe. So now let's move to the question number 3. A person is standing on a boat and jumps forward. What will happen to the boat? The boat remains stationary, the boat moves forward, the boat moves backward.
I would say it's C.
Backward.
Backward. Boat moves backward.
Yeah, because the boat and the guy is doing
If the
suicide.
force will be out in
Yeah,
opposite
if
direction.
exactly. So if it is in forward direction, so it will be in backward direction. The moon is saying the guy is suiciding. I don't mind. Anyways, guys, I hope this concept of Newton first law, second law, and third law is clear, and you guys can use this formulas for making, because these are simple questions. Okay, this question is simple, no doubt. This question is simple, no doubt, and this question is simple, no doubt. But now we are moving forward with more complex questions. So I hope this concept will help you to evaluate yourself and to get more understanding on the complex concept too. All right. So what's the time right now? 10:46. Okay, we will be taking a break at 11 or 10:55. 11 is better. 11 break, and then we'll start a second session. Perfect. So inertia is clear, guys. Contact, non-contact force is very simple. I will just read it for you because it's not something to remember, and I don't think so. I might ask a lot of questions on this. So contact force means requires two objects to be in physical contact. Easy, everyone knows it. Typically caused by physical objects, such as when two objects rub against one another. Again, easy. Typically localize and affect only the two objects that are in contact. So contact force affects both the body, no doubt. Non-contact force acts typically caused by energies such as light, sound, and magnetism. Electrostatic force is non-contact force. Gravitational force is non-contact force. And now you will say me that you're getting contacted on the ground. Why it is non-contact force? So it is contact plus non-contact force. That is different thing. For example, Earth and Moon are in contact, but they are not connected with each other. That is the reason they are not contact force. Let's understand the sort of forces by some examples. Okay. Okay, I think non-contact and contact force is quite easy, and I don't have to tell you more examples about that. Let's move forward with the friction and gravity, because this is important, and because most of the questions in Imat they are asked from no, before that I need to give you a clear concept about yeah. Sorry. Okay, let's take a key summary, whatever we have learned, and then we will move forward. Key summary. Okay, guys, one more thing which I forgot to inform, very important, is that, for example, this is a object, and this is a guy, and if he is in contact with the ground, so he will be applying a force is equals to, since you know that acceleration and g are the same, but g is acceleration due to gravity. Yeah, so acceleration due to gravity. So if I write somewhere f is equals to mg, don't get panic or don't get heart attack in yourself. No, it's not a big thing. It's just g is can be written as a as well. But we know that g is always constant in the planet Earth. So that is the reason I'm using the word g here. So whenever I'm standing here, the force which will be applied will be f is equals to m into g. Okay. So this thing is important. G and a are same, but g is referred as acceleration due to gravity. So now yeah, this was what I want to say. Yeah, one more thing. Okay, let's understand the concept of difference between mass and weight. Mass is always constant and weight can change. Let's take a beautiful example. Let's take an example of mass of Amir. That is me. On planet Earth, I'm 65 kg. I want to increase my weight anyways, but it's 65 now. Or make it 66 because it's easier for calculate for me. Okay, on Earth it is 66, and mass is 66. Yeah, this is mass, not the weight. This is mass. The weight will be 66 into g, that is 10. I'm taking g as 10. Well, it is 9.8, but you can take 10. It's fine. So it will be 660 Newton. So the SI unit of weight is Newton. Now, if I go on a moon, my mass will remain same. My mass will remain 66 kg, no doubt. But my weight will be 660 66 into, okay, 660 into 1 by 6, because on moon, whatever we are here on moon, it become 1/6. So on moon my weight will be 110 Newton. So you see that the mass remains constant for me on earth and on the moon. On earth it was 66, and also on moon it was 66, my mass. But my weight on earth was 660 Newton, and on my weight on moon was 110 Newton. So I hope the concept of mass and weight is clear for all of you. And weight is written as W, and the formula is mg, the same. Okay, so I can write, so now what I can write is, I have learned 5 formulas so far. Force is equals to mass into acceleration, force is equals to mass into gravity. Yeah.
Sir, can we say that weight is the force towards the earth?
Yeah, exactly. That's the same thing. Yeah, you can say it. Impulse is F dot delta T, and M dot delta V can be written as F dot delta T. And what else I can say? Any other formula which I have taught you guys so far? No, yeah? Perfect. Yeah, that's all. So we have learned these formulas, and these formulas are, I hope, clear to everyone. In kinematics also we did a lot of formulas. Now also we are doing, so make a formula sheet for you, better for your understanding. Of course I will be sharing the formula sheet at the end of the lesson after 3 months, but not now. Now you can make by your own self. Okay, key concept whatever we have learned is, we understand the concept of mass. One second, a measure, where the hell is it? Okay, a measure of body's resistance to acceleration. We understood it with the help of F is equals to ma. The SI unit is kilogram, and the International Bureau of Weight, according to that, we made it kg. And this SI, you don't have to do anything with this thing. No worries. It's SI unit system. For force, it's, the SI unit is Newton. Net force we have yet to discuss. Object continues, we did it. Second law we did it. Third law we did it. Now we are going forward with friction force, normal force, action reaction we did it. Tension force and drag. So now we are going to move with friction, normal and drag. And I think it's the time for break now to all of you, and then we will start another session of 1 hour after this, and in that we will be starting with friction and gravity. Have rest, and until the time I will charge my laptop.